This is Algebra 1. We're starting our new unit, and we're starting off the unit with this activity, how do you cross the river? So while you're watching this video, I'm intending the first part of each problem to be a hint. That way you can stop the video and then continue the problem on your own. In general, you should be able to solve each of these problems by yourself, and then you're watching this video at the very end to check your work. All right, so let's read. We have 2 adults and 2 children, and they're needing to cross a river in a rowing boat. And there's no trick oh, well, maybe they can jump from rock to rock. They have to go with the boat. All adults weigh the same, and each child weighs half as much as an adult. The boat can only carry the weight of one adult. There must always be someone in a boat to row. You can't just send the boat and shove it to the other side. Can you figure out how to get them across? All right, so use the colored chips to find a strategy for getting both adults and both children to the other side of the river. If I were there, I would have been able to give you chips, but you guys can use, if you have pennies or nickels or something like that, you can play with that. Let me go through the strategy for number 1. I don't have colored chips, so you can just figure it out on your own. I'm sorry, guys, I'm not there. So let's go ahead and think, what if I had 1 adult? So let's say A for adult and C for children. If I had adult 1 go to the other side of the river, that's a problem because there's no way to send the boat back across because that adult 1 would just have to come back. So we cannot send an adult over first. We have to send over a child first. So if the boat can only carry the weight of 1 adult, that means it can carry the weight of 2 children. So what I could do is I could start with having children 1 or child 1 and child 2. If they go across, then they can send someone back, right? They can send child 1 back. So maybe child 1 can come back and child 2 can stay over here. And now, technically on this side, we have adult 1, adult 2, but child 1 and child 2 went across. So at this step, we have child 1 is going to come back, and child 2 is on this side. Adult 1 and adult 2 are still on this side. So if child 1 comes back, then we have child 1, adult 1, and adult 2. Okay, well, we're trying to get adults across, so we might as well do that now, right? And at this point, you can probably see the pattern, I'm hoping. So let's go ahead and say, let's send this adult 1 over here. So currently what we have on this step is we have adult 1 and child 2 on this side, and we have adult 2 and child 1 on this side. Let's go ahead and we're trying to get this adult to the right side, and we're done, so we don't want to undo that work. The boat is currently on the right side, so we need to move this child back. So we'll say child 2 will come back, and that leaves adult 1 on the right, and now we're left with adult 2, child 1, and child 2, and then we're kind of back to the same scenario that we were before. We have 2 children on the left, and we have an adult or so on the left as well. So what is the next step here? And I would, if you're watching the video for a hint, you should stop now and try it on your own. All right, so now you're watching because you're either still stuck or you're checking your work. So this is the pattern over and over again, where you always have 2 children on the left, which means both of them are going to go to the right. And I think I can summarize this in a smaller chart, which I'm going to do now. So let's go ahead and do it this way. I'm going to say this area here is too big, so I'm just going to go ahead and do this. I'm going to say that if on the first trip across, we have child 1 and child 2. And then on the next trip back, we have just child 1 coming back. On the next trip forward, we have an adult, so we'll call that adult 1, that goes across, and then to come back, we have the second child, child 2. And at this point, this kind of repeats. So this is kind of my building block that repeats. We'll say I keep going across, so I'm going to do kind of the same thing now. We have child 1 and child 2. Again, I'm repeating this step down here. And then coming back, we have just child 1. And then to get across this way, we're going to have adult 2. And then we're going to have, again, child 2 is still on the right-hand side, so we can have child 2 come back. So we can have child 2 come back. And then at this point, the only people on the left are child 1 and child 2, so they need to get across. So we'll come back and say child 1 and child 2 will come back. And you'll see that that looks very, very similar to what we just did. So this block right here looks very, very similar to this block up here, right? So we have a block of 4, pen. We have a block of 4, and then the final child 1, child 2 coming back. They're kind of like the helper children. So we figured it out, number 1. Now we're on to number 2. If I count up each of these lines, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 trips back and forth. So there's a total of 9. So the minimum number of trips you'd need to get everyone across is 9. All right, we're on number 3. If there is only 1 adult and 2 children, what is the minimum number of trips needed to get everyone across? And again, my hint for you is there are less building blocks over here. All right, I'm assuming most people didn't need the hint, and you're coming back now for the solution for number 3. But the answer is it's 5, because essentially what I'm doing is I'm crossing off this entire building block. And if I look just down here, I have the same setup where the 2 children go across, children 1 comes back, child 1 comes back, adult, there's only 1 adult, I guess, that goes through, the second child will come back, and then both child going forward. So it's all of these 5 steps for a total answer of 5. All right, next we're on number 4. What if there were 3 adults and 2 children? So we had 2 adults, then we went to 1 adult, now we're going to 3 adults. What is the minimum number of trips needed to get everyone across? And my hint for you is there's going to be, instead of 1 fewer block now, there's going to be 1 additional block. Okay, so that was your hint, and you're pausing the video now. And for those of you that are coming to check your answer, here is the answer. The answer here is 13. And the reason for that is these blocks over here, each block has 4 moves, which means we need an additional 4 of these moves. You need a child, I guess all 4 of those get repeated again, and that will get 1 adult across while having 2 children still remaining on the left-hand side. So the correct answer here, 13. I guess I should have units here. There's 9 trips, there's 5 trips, there's 13 trips. All right, and what if there are 4 adults and 2 children? You probably don't need a hint for this because you've found the pattern by now, so I'm going to jump straight into the answer. There's 1 additional block, and each block has 4 additional moves. So we're going to add 4 to 13, and we get a total of 17 trips. And what patterns do you notice in the number of trips required when an extra adult is added? And hopefully you're seeing for number 6 that it's just these additional building blocks added on. So you can say something along the lines of, oh wait, did I miss something for number 5? Oh shoot. No, yeah, okay, I got it. So in number 6, we just say add 4 trips for each new adult. And I guess we could be a little bit more specific about why that's the case, using words to say it's kind of shuttling 2 children across and then 2 children back. Takes up 3 steps with 1 adult going forward. So you can say 3 trips to move the children, and 1 trip to move the adult. All right, note. What is the minimum number of trips needed to get 2 children and n adults to cross a river? So this is probably the penultimate task. Essentially what we were doing is we were finding a pattern, but you have to generalize a pattern. So this could be 100 adults, 1,000 adults, and you can still get the right answer. So we need to make a formula. And the way to do that is we need to look at a pattern. And the way that I'm going to solve this is with a table, but you can solve it in any way that you want. So I don't really have any room for a table. I think I'm going to have to just write small down here. So I'll say that this is the number of adults, and this is the number of trips. The number of trips depends on the number of adults, which is why I have the number of adults on the left. Usually my input is on the left. What we've done so far is we've had 1 adult, 2 adults, 3 adults, and 4 adults. And the number of trips, so what was it for 1 adult? For 1 adult, that was 1 adult right here, so that was 5 trips. So for 1 adult, that was 5 trips. 2, we added 4 to that, we got 9. We added 4 to that, we got 13. We added 4 to that, we got 17. And that was the pattern, right? To get from 5 to 9, we added 4. To get from 9 to 13, we added 4. To get from 13 to 17, we added 4. One thing that I think would be maybe helpful as my hint before I actually reveal the answer is maybe try to find what would happen if there were 0 adults. How many trips would it take? And again, that's the case where you just have 2 children then. If you have 2 children, watch, right there. I guess technically right there too, huh? You just have child 1, child 2 go across in 1 trip, and it's not even a puzzle anymore. The answer down here would be 1 trip. And again, that still follows with our pattern, because if I add 4 to that, I get to the next step of 5. Okay, so that's my hint. Go ahead and pause the video if you just were here for the hint for number 7. And then I will reveal the answer now that you've unpaused the video. So no matter what, we're going to have one trip across. And then every time that we add on a number of adult, essentially I'm doing 1 times 4 plus the original 1. So 1 times 4 is 4, plus 1 is 5. 2 times 4 is 8, and I have to add the original 1. 3 times 4 is 12, add the original 1 to get 13. 4 times 4 is 16, add the 1 to get the 17. So essentially I take the number of adults, I take n, and I multiply it by 4, so I'll say 4 times n, and then I always have to add 1, because this was the move from the original children moving across on this step right here. And you can test this to see if it works. So go ahead and plug in 2. Plug in 2 to n. It's going to be 4 times 2, which is 8. 8 plus 1 is 9, and 9 is indeed the answer. You can do this for any of these numbers, and they will work. And they work all the way out through 100, 1,000. It's called an explicit formula, so you can jump to any answer that you want. So that's the solutions, but I want to mark this up a little bit. Let's go ahead and do this. So typically speaking, in this unit, what I like to do is anything that I write in red is kind of like the teacher draft or the second draft. So if you could write this with a pen, I would appreciate that. But on Tuesday, I'll be giving you guys a little bit more direction on how to use different colors to mark up our notes. One thing that I want to note about this is something I've already said, but I want to write it down. This +1 is the trips needed with 0 adults. And I hope you're okay with this notation. That's how I write the word with, just W with a slash. And what is 4? 4 is the additional trips needed for every adult. So I'm going to write that down. Oh no, that's a weird T. Trips needed for each additional adult. Excellent. Well, I hope that you guys had fun without me, and I hope this wasn't too hard of a task. That concludes this video, and that means you guys are done for the day because there's no homework after this. I'll see you guys tomorrow.